Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 33, search in rotated sorted array. It's very important questions to understand how we can solve the problem in O log n. So basically we have given the array we have given, right? And this array is sorted in such a way that it is rotated also. So let's suppose it is rotated by these elements from the left side, and then we have some element after that, which is it should be in the beginning because it is rotated, so it should not be here. It's fine. Like we have given sorted array that was sorted and rotated, we can say. So at some pivot, what is that pivot, that we'll understand here. So let's suppose we have a target. If the target matching the pivot, right, we have to return that pivot index. Okay, so let me show you first. I'll go through the explanation so you will understand. Okay, yeah, or I take it here. Okay, the very first thing what you should understand is you should understand what we have given. The given thing is, let's suppose we have some original array we have given, right? And the original array is sorted. So whenever I'm talking about, it's a sorted, let's suppose, right? When it is not sorted, I will tell you. So let's suppose that this array was previously, it was given like 0 1 2, and then we'll say 4 5 6 and 7. Okay, we zoom out a little bit. Okay, so you can understand, right? Very first thing it is saying, we have given an array which is like this, and this array is your original array, and it is original array, and it is sorted array, we can say that. Okay, this is original array. Now the question is saying that after this line, it is saying that it is rotated, means after rotation, what is the array? It could be 4 5 6 7 0 1 2, like this, you can say that. Okay, so this part is sorted, the very first part is sorted, it, and this part is also sorted because this was the sorted array. So if I'll connect all of these, right, it will look like this, right? Correct, we can say. And you need to find the index of target. What is the target? Target you have given here, right, like this. So let's suppose that in this array, this is the array we have given, right, after rotation, right, after rotation array we have given, and target we have is 0. So it is saying answer is 4. Why? Because 0 is existing in this array at this index, because this index is what? 0 1 2 3 4 5 6. This index is 4, and that is your answer is coming 4, right? So the array has a distinct value, which is important because it is not not indistinct, means not a duplicate values contains, it is a distinct value, right? So the very first what you should understand is the normal array, right? Normal sorted array look like this, right? And after rotation it may look like this, right? So usually we'll go this problem, like if the target we have given and we have to do searching, and we have to do with the log of n time, right? So we'll not go with the linear search, and you cannot directly go with all the passes because it will take O of n time. This is the problem with this approach. You cannot use the linear search. So here you should use the binary search, where what you need to do is, I'll show you. Give me 1 second, guys. I'll keep it little this side. Okay, now I'll increase little zoom. I hope you are you can see, right? Okay, little bit increase. Okay, so now think, if we'll say that this array contains, let's suppose like this, we have an array that we have seen, right? The very first index 0 and the last index is n minus 1, right? Means I want to put at index 0 is left, and here at index I want to put as a right. I'm talking about the generic value. Okay guys, it can be anything, any value could be here. Okay, so in our case, let's suppose that if I'll talk about little bit, right? So what we have here, we have is, we have 4, right? So we'll use left here, and at index 6 we will use the right, correct? So where the mid will come, obviously the mid will come here at this index 3, so you will get the mid here, you can say. Okay, I'll say the mid. So if you know the binary search, in binary search we take left and right both indexes, and there will be a mid. And mid, what we will do, like we'll do left plus right minus left plus right minus left by 2 will do, and we'll find the mid element, right? Now you will check with the mid element. If the mid element is matching, right, it means what? So there is a concept here. So even though the whole array is not sorted, right? If you see this array, the overall array is not sorted. It is partial sorted, means the very first part from here to here is sorted, and then from here to here is sorted. Means there is two part, right? So we can say even though the whole array is not sorted, one important fact is always true. In a rotated sorted array, at least one half is always sorted. Either will take this half or either will take this half, right? So we can say that, okay, there is some middle element will be there. Let's suppose middle element will be there here. Let's suppose this is our mid. So from this part or this part, any of this part will be sorted. Okay, so let's assume that I will talk about in our case, this case, right? Let's go here and understand. Now we should think about, let's suppose the very first half, what is we have in the left half. Okay, so in the left half we have is 4, 5, 6 and 7. Am I correct? So this is the array we have in the left half, right? We are talking about the left half, and this is also sorted. So left half is also sorted, we can say. Okay, now let's go ahead and say what is about the right half. So we'll say right half is 0, 1 and 2, and it is also looks sorted, right? So we'll say this is also sorted. In our both cases, either left and right both are sorted. This is also sorted in this case, right? But generally in every binary search step, either the left or the right half, either of this left half, either this left half or either this right half, means I'm talking about this part and this part, right? So either of the left or right half will have definitely a sorted one. Okay, so we use binary search, but with one extra check we will do, which side is sorted, this side is sorted or this side is sorted. Okay, so if we will add one more extra check, that which side is sorted, and then we can say can the target lies inside the left side or in the right side, means can the target lies inside the sorted side or the not sorted side. So that is the extra check you have to do with the binary search plus one check, you can say. And that one check we need to do is, can, let me, okay, yeah, so this one check is what, guys? This one check is, we can say, can the target lie inside that sorted side? Like that you can ask to yourself, right? And then you can find that, can the target, okay, this is your target, guys, okay, this is your target, can the target lie inside the sorted side? That is a normal thing. Okay, and in normal binary search, what we need to do is, let's talk about the core idea so you can understand. Okay, the very first thing in normal binary search, what we used to do, the very first we'll say, okay, if you have a target and if target is less than nums at the mid, right? We can say, if this is the case, if target is less than the nums of mid, it means we have to search left, correct? Or else you search the right. Am I correct? It means the very simple logic is, if the target is less than nums, we'll check in the left side. If target is greater than nums at mid, means we have to search in the right side. But in sorted array, the simple logic doesn't work, right? So what we need to do, we have to check that, okay, let's talk about the given things that we have, right? Or let me zoom out a little bit. Okay, so I'll keep it here so you can understand. Okay, I'll keep it here, guys, you can understand. Okay, now what I'm trying to say, that this is this is, we are talking about the normal binary search. But what about in the rotated sorted array, sorted array, right? What about this one? So that we are going to talk about. So we have seen that we have given the array, right? And we have to find in the let's suppose the array was 4 5 6 7 0 1 2, right? These are the elements we had, right? 0 5 6 7, right? Okay, like this. And we have target is 0 and we have mid is 7, right? This is 0, this is 7, like that we can say. Here 0 is at this position, right? It means our mid was here, right? So can we say that target is less than mid, right? This 7 is greater than 0, so we'll say, okay, in our case here target is less than the nums at mid, we can say, correct, guys? If it is less than nums at mid, but the target is actually lies on the right side, right? This part, this is our right, and from here to here is the left, right? This part. It means, so instead we ask, is the left sorted and or left sorted or right sided, right? We should ask what? We should ask that, is the left half sorted? If yes, check whether the target lies in it, right? If it lies in it, then go to search in the left side, then in the right side, and so on. And similarly we'll do with this one. Means basically we have to do the binary search over here or here, but before that we have to check that, right? So I hope you understand. I assume that you are understanding, right? So let's try to understand how we are going to solve. Okay, I'll explain you again, don't worry, I tried my best but it's okay. Okay, so let's talk about here the very first. Okay, so as we have discussed, let's write first the left. So we have written left here, okay, and the left should start from where? From the 0, correct? Then we will write int right, and this right should be at nums dot length -1, correct? Simple. Then for the binary search, you know that if it is binary search, we have to check that if left is and right is matching this condition, means left is less than right, it means we have compare both spaces, right? Left part and right part, right? So we will stop that. Until that we will keep moving. Then we'll say, okay, let's find the mid now, right? So to find the mid, what you need to do, you will say, okay, left plus, you will do right minus left, like this, okay? And then you will divide by 2, as simple. So this is the way we find the mid, right? This is the binary search, right? We know that this is the template. Now very first you have to say find the target. Find the target. How will you find the target? So very first you will say, okay, if, I'll say if nums at mid is equal to our target, correct guys? If it is equal to our target, it means what? We should return here the index, right? And that index is mid. So we find, now we have found the target. So we'll say, okay, target, we found the target, okay? Or we can say let's found, F-U-N-D. So let's say that we have found the target now. Now if we have not found the target, because the target mid is at 7, right? And that is nums at mid is 7 right now, and target is 0, so it is not matching, means we have to go to ahead, right? So it means there is some cases will happen, okay, that we should talk about. The case one will say, okay, left half is sorted. If the left half is sorted, then we'll say, okay, if the condition saying that nums at left, if nums at left is less than equal to nums at mid, it means it lies in the left sorted. I'm not talking about the left side, I'm talking about the left half, complete array, half array we are talking about, right? So we'll check some data here, okay? We'll create the logic, IMPL logic, I'll say letter for left half. Okay guys, then I'll come back here, don't worry, I'll come back here and then we'll talk. Otherwise there should be a else condition also guys. Say else what means, this else is for, let me write here so you'll understand. So this else is for case 2, correct? Case 2, and case 2 for the right half. So we can say right half is sorted. Can we say the right half is sorted? Good. Then what we will do here, then we similarly we will implement our IMPL logic here. We'll say the same thing here, okay, for right half. Okay, I'm coming back to here, right? And in else condition, let's suppose we'll go for the while loop. Let me create the first template. If it is not finding in the left and right half and at the mid, it means we don't have that element. So we'll say -1, we will return -1 will return here, okay? So this is what we are going to do. Now let's talk about the left and half part, because the array could be array is rotated, and the left part is maybe our target lies inside the sorted left half or in the sorted right half, right? So we'll implement both logic here. The very first implementation logic should be here is, we'll say target lies inside the sorted left half, okay? Like this, we'll say the target lies inside the sorted left half, okay guys? in this case you will say if nums at left if nums at left is less than equal to our target, okay, and the very first is left, nums at left is less than target, right, less than equal to target, and our target is less than our nums at mid, correct? We should check that also, right? It should be, the target should be less than nums at mid. So currently our target is where? Target is 0 and nums at mid is what? Is 7, right? And nums at left we have 7 and it is saying less than equal to the target, right? So nums at left is not less than equal to target. The very first part, this part is not matching, correct? I'm talking about this part. It means it should go into the right half, but still we have to make the logic, right? So we'll say that, okay, we'll do the dry run, guys, don't worry. Okay, so we'll say, okay, if nums at left is less than equal to the target and target is less than the mid, it means what? We have to say that update the right from mid -1, correct? As usually we used to do in the binary search, right? That part we will do. If it is not the case, right, it means what? There should be a else condition. Any else condition will say, okay, our target lies in the other half. It lies in the other half. So we'll say, okay, in else condition, we'll just write what is the left now. The left is mid +1. I'll talk about it, don't worry. Okay, we'll do the diagram so you'll understand. So this part will happen, right? Now similarly we'll implement for the right half, right? The right half implementation we'll do. So the very first thing is we'll talk about the target lies inside. I know that you are now understood and you can do by yourself, but it's all right. Let me write it. Okay, the sorted right half. Okay, means the target lies inside the sorted right half, correct? And for that you just need to do, make a condition and say that nums at mid should be less than target. If nums at mid is less than target, right, and target is less than equal to nums at right, we can say, in this condition, right? Then you will say, okay, our left is mid +1, we can say, as we have done for the right, we do the similar things. Otherwise say, okay, it means your target lies in the other half, correct, guys? So we'll say, okay, go with the else condition and you just say else. In the else condition just say that right is mid -1, as we have done in the other half, right, in the right half. Like this we will go and we'll do. So what we need to do is, very first thing we have to check the condition. We have start from the left and right, then we'll go for the while left is less than equal to right, and we'll find the mid. We'll check on the mid. If find the element, we return from the mid. Otherwise there will be two cases will be there. The case one, you will check in the left half or you will check in the right half. Okay, if condition doesn't matches, you will return -1. Okay, so yeah, Yes, here you can keep it. Okay, let's keep it here. Okay, so we have seen that our elements was there, right? So how we'll solve this problem, right? Basically we have given is 4 5 6 7 0 1 2, like this. We have seen that we have given, okay, arrays. Okay, so let me write it. Okay, so this part is left and this part is right, correct? And we have seen that target is 0 you have initially. Okay guys, so when we talk about this one, right, we have put our left here and right here. Okay, so if, and this is our mid, so target is 0, mid having 7, and it is not matching, so it will not go in this code, right? If it is same, if target is same, we will return this index. Okay, otherwise in this case target is 0 and the mid having 7. Okay, so what we will do, we'll check with the nums at left. Nums at left is 4, nums at mid is 7, it is greater than, less than, equal to 7, right? It means the nums at left is less than nums at mid, means left half is sorted. That we will check, right? Means it is sorted. We can say, is it sorted or not? So this will decide it is sorted or not. If it is sorted, we'll go in this logic. Okay, in otherwise cases we'll come to the right part. So this is sorted, so you can check in this part. Similarly, you will check if you will update the value, right? You will check that nums at left target matching, right? If it is nums at left which is 4, which is less than equal to target, it is less than but not equal to, right? So we'll say, okay, if this is less than the target, so we'll say fine, but target is should be less than equal to mid, that is also fine. So we'll update our right. Okay, so let's suppose our right is here, so where it should go, it should go this side, right? Like that we can say that. Similarly, we'll check in this side, the right half is sorted or not, so we'll check in this side. Okay, so nums at mid is, we have is this value, right? Mid 7, and target is less than, so it is matching the value. It means our left will update it from here to, it will go to this part, right? And similarly you will update the mid plus 1 left because we have updated, and similarly you pass the mid minus 1, you will check that right will get updated. If in other cases, this case is not happening, but fine, like that you will go and you will check that. So this condition will keep going on, and you will find sometime here that your nums at mid is equal to target, and so you will return your target. Okay guys, if in case you have not understood, let me know the comment section. I'll do the dry run there so you can understand. Okay, let me check the code. So all the test cases are working fine, and this will work. So code is already accepted now, so that's fine. Okay, so use this code and try to understand. If you have any doubt, you just ping me in the comment box. It's very easy problem, and that's all I have in this video. And if you talk about the complexity, you know that why we have come to this place, and why we have used this binary stores, right? We have not used the O of n log, but we wanted to use the solution which should stay in O log n. Okay, so the time complexity is O of log n, and the code is getting accepted. Thank you guys. In case if you have any suggestion, doubts, please let me in the comment section. And if you are struggling with anything, please ping me in the comment box, or you can come to our WhatsApp channel and you can join there. That's all in this video. Thank you so much. I'll see you in the next one.